Hi, thank you for your interest in our study. My name is Muyang Li. I'm going to present the study, Awareness, Understanding, and Action, a conceptual framework of user experiences and expectation about indoor air quality visualization. This is a joint work of Professor Sunyoung Kim from Rutgers University and myself. We are facing several facts regarding to this topic. People are spending majority of their time indoors, so that indoor air pollution may seriously impact their health. Lots of indoor air quality monitors can be found on the market for people's daily life. However, there is an absence of studying the design principles for effective indoor air quality visualization to help people to better understand and improve their indoor air quality. This paper is studying this issue. Our study builds on the previous work about persuasive technology and eco-feedback systems. Persuasive technology is the technology designed to change attitudes or behaviors of the users through persuasion and social influence. Eco-feedback system is the technology that provides feedback on people's behavior and how their behavior will affect the environment. Previous studies have figured out several design components that relate to the design of indoor air quality visualization. They are historical comparison, normative comparison, reward and penalization, incentives, and disaggregation. To collect data, we searched monitors on the US Amazon and applied criteria to get a list of 10 devices as the image shown here. By considering the degree of users' engagement, we dropped the 3 devices on the far right side of the 10 because they just simply displayed air pollutants data on the screen without any further design. We collected a total number of 1,447 reviews of these 7 devices from Amazon and used gradient theory to analyze them. After analysis, we got 3 themes as a procedure of how users process indoor air quality visualization, including awareness, understanding, and action, and 2 themes as outcomes of using indoor air quality visualization, including knowledge gain and a feeling of relief. As we can see from the figure in the PowerPoint, several design components or considerations have emerged within each theme. We found that the user's first reaction to using an indoor air quality monitor was an increase in awareness about indoor air quality related issues. The first design component to increase awareness was the use of ambient light. We found that all devices adopted ambient light as an important design component to provide the current status of indoor air quality. Examples can be found on the PowerPoint. Majority of the users left positive comments about the effectiveness of the ambient light to allow them to easily engage. There was also a number of complaints said that the change of ambient light unintentionally interrupted their sleep. Some devices have taken this problem into consideration by adopting an automatic dimming feature. The second design component was the use of color code. Every device with the ambient light feature we've studied adopted the color-coded theme. It changed the color of the ambient light based on the level of indoor air quality. Usually, green and blue for good indoor air quality, orange for moderate, and purple for bad. Majority of the users had positive comments because it was simple, intuitive, and easy to use. The third design component was the use of notification. Many devices designed a notification feature to inform users of critical information when an abnormal indoor air quality event happened. Particular design of notification included playing a beep song, blinking LED light, and sending an alert notification to a mobile application. Many users left positive comments on the effectiveness of the notification. One of the reviews said that we love the ability to get notification when an air quality index goes over a user design threshold, so we don't have to always check on it. Having the increased awareness, users intend to build the better understanding of the specific indoor air quality situations. we got three themes that influence the understanding of indoor air quality information, including data quality, data type, and data presentation. We got two aspects of data quality that contribute to understanding of indoor air quality, including accuracy of data and completeness of data. Indoor air quality visualization applied design components such as historical comparison and normative comparison to help user approximate accuracy, which will be mentioned later. Users said that devices monitored a wide range of air pollution had good quality data. Proper visualization can effectively inform user which type of air pollutants and monitor measures. User can easily understand the scope of pollutants. The second theme to increase understanding of indoor air quality visualization was the data type. We got three types of them. The most commonly used type was numerical sensor readings. For example, CO is 28 ppm. Sensor reading like this might not be effective because users had limited knowledge to interpret the meaning of the number. To improve such situation, many devices applied icons and color codes to convey contextual information along with the number. Good examples can be found within the study. The monitor on the left side in this PowerPoint used a fresh leaf icon to represent for good indoor air quality, and the monitor in the middle used a yellow frowning face for a moderate indoor air quality. Another common type of data was indoor air quality score. Most devices presented a percentile of the score to provide an overall rate of indoor air quality. For example, the monitor on the right side of the PowerPoint, it measured the indoor air quality level as 86 out of 100. The indoor air quality score was easier for users to interpret than the numerical readings, but it still caused problems of interpreting the meaning behind the score. This problem can be solved by using a design component of disaggregation, which will be mentioned later. The third data type was Air Quality Index, short for AQI, an index to report the condition of air quality. The table image on the left side of the PowerPoint was the AQI published by United States Environmental Protection Agency. It provided information to corresponding air quality values, health concerns, and colors as national air quality standards. All the devices we've studied adopted this AQI's color as color codes for visual components such as icon, graph, and ambient light. We didn't find any reviews about AQI. The third theme to increase understanding of indoor air quality visualization was the data presentation. It was the key part of information visualization to help users to interpret the meaning of the data. We got three design components here. Historical comparison was designed to provide a current indoor air quality status relative to the past using a graphic chart. The monitor on the left side of PowerPoint designed the historical comparison as abstract as dots, and the monitor on the right side presented historical comparison at the bottom of the display. The historical comparison turned out to be an effective method to allow users to easily explore, track, and analyze the pattern of indoor air quality changes. The second design component was normative comparison that compared one's indoor air quality with other places. We found that the majority of devices were limited to provide outdoor air quality for normative comparison. One of the reviews possibly mentioned that it has a fun feature that allows you to view the global air quality in a Google Earth-like perspective. The third design component was disaggregation, to allow users to disaggregate the overall information into specific, detailed subcategories. But we didn't find it in any of the devices we've studied. However, we found numbers of complaints about the lack of disaggregation in the reviews. Followed by the awareness and understanding, users quickly took proper actions to lower indoor air pollution. We got three design components to improve user action, including recommendation, automation, and data export. We found that several monitors and their mobile application provided relevant tips and recommendations to improve indoor air quality. Many users mentioned that they need those recommendations a lot when dealing with air quality issues. We also found that the contents of some recommendations were limited to simple suggestions, such as open or close the window. One of the reviews said that, "I found the tips in the app to be a little bit too simplistic. I wish the tips were a little bit more explicit and individualized." The second design component was automation. Some of the newly released monitors were equipped with this feature to turn on or off the indoor air quality related equipment such as an air purifier. Users left extremely positive reviews on this feature because they made no physical efforts to initiate action of improving indoor air quality. The third design component was data export. Some users turned out to be very proactive about monitoring their indoor air quality and wanted to be actively engaged in analyzing the current and historical indoor air quality data. With all the devices we analyzed, no one provided the download feature. Finally, I would like to introduce the outcomes we identified that the users would enjoy in an indoor air quality monitor. Our findings confirmed that users considered knowledge gain as the crucial benefit of using an indoor air quality monitor. Many users reported various types of information and knowledge associated with the possible sources of indoor air pollution and interventions for poor indoor air quality they newly uncovered. This information finally turned into their own knowledge to deal with the indoor air quality related issue. The second outcome was users' intention of gaining emotional feeling of relief. One of the reviews said that, "Keeping my indoor air quality monitor on all the time and checking it occasionally allows my family to rest easy, especially with a toddler around the house." Our findings echoes the importance of ambient awareness, the unique design component of persuasive technology to make users aware of quality of their environment. We suggest that it is essential to take into consideration of ambient light as an important design component of indoor air quality visualization as an ambient display. We also note that the automation can be very important for the future design due to the increasing popularity of smart home technology. It is very important to balance the amount of automation and user engagement to avoid users' feeling of overwhelmed and to facilitate their abilities of understanding the problem. Our findings of the three design components of data presentation, including historical comparison, normative comparison, and disaggregation, are not surprisingly overlap the design components of eco-feedback systems. The other two design components of eco-feedback systems, including rewards and incentives, are not emerged from our study. We assume that there are potential to expanding and combining these two design components with the other components to facilitate the user engagement. This paper is the first attempt to conceptually frame design consideration for indoor air quality visualization. We hope the framework of explaining the process with the proposed set of design consideration can provide valuable design strategy for the future design. Thank you for listening.